So that's what causes it to go up. And then you mentioned it earlier. What causes this charge to then go down again?
The closing of those gates and the opening of the potassium voltage gates.
How come the potassium voltage gates don't open? Why don't they open here also?
It's like, from what I understand, it's like they are opening there, but it's just because they open up slower, and then at the peak is when they are fully opened.
Yeah. Yeah, so once these gates all close and the cell is just resting, no action potential, there's little gates that are always open, which are the potassium leak channels. And you're right. They leave because of the concentration, because there's higher inside, and they come back in because of the negative proteins are attracting them back in.
Okay.
So just be aware of that's that kind of electrochemical thing, and it's not just black and white. It's just it kind of it's an equilibrium being reached. But so we're at this point. Goes down. What's the next step?
The potassium gates close too.
Yeah, it closed also. And then what reestablishes it at its resting membrane potential?
The only thing I can think of is just active transport.
That has something to do with it, yeah. Because what is that doing? What pump are you
Well,
talking about?
That and then, gosh, I'm not even sure though.
Scary, Sodium potassium pump. Heard of that?
Isn't sodium potassium pump the active transport?
Mm-hmm.
Okay.
Yeah. So that's what so that has something to do with it. It pumps sodium out, pumps potassium in. But the main thing that determines where it settles is those potassium leak channels. Because they're always open. So right here when it's too low, a lot of potassium will it kind of reaches an equilibrium when the same amount is coming in as going out, then it stays around -70.
So hyperpolarization is just kind of just getting it back to normal. They're just kind of going out and getting it back to normal. Is that kind of what it is? Or?
Hyperpolarization means going below the resting membrane potential. So anytime it gets below it, like right here, that's called hyperpolarization.
Okay.
But you're right. In that point, it does come back up to resting membrane potential.
Okay. So then what's like the absolute refractory period and the resting membrane? Or no, I know what that is. But like the relative refractory period and the absolute refractory period.
Woody, you have any
Yeah,
ideas?
that's something I want to get cleared up
Okay.
too.
It's actually it's pretty simple, pretty straightforward. The absolute refractory period. Well, first, what refractory period is? It means the action potential can't happen again, or it's going to be really hard for it to happen again. And it's talking about at certain points in this cycle. So when it's above threshold, this whole thing, that would be absolute refractory period, because it's in an action potential. It can't just do it again right away. It's already in it. Down here in the hyperpolarization is the relative refractory.
Okay.
And that's because it could happen, but it's going to be a lot harder because it has to come all the way up, yeah. So relative, it usually doesn't, but it could. This absolutely can't. It's impossible.
Okay.
Any other questions, terminology, or?
What does chlorine have to do with this? Because I feel like it'll be on the test because we're supposed to understand it, but I feel like just making sure we know the same thing what happens with chlorine in this process.
Yeah, that's a good question. So these neurotransmitters that were released let sodium in, right?
Mm-hmm.
And sodium coming in makes it get closer to action potential, closer to threshold. Another nerve could be over here, and instead of exciting the cell, causing it to go up, it could inhibit it, causing it to become more negative. And you could release neurotransmitters that bind to different ligand gates, that when they're open, they let in chlorine. Then what that does is make it so the cell stays inactive. That make sense?
Mm-hmm.
So that's the role of chlorine, because it's negative. It'll come in and drop the charge.
So sometimes when the potassium gates close, there are calcium gates that are open, and there's chlorine gates that open, and the chlorine sometimes attributes to the hyperpolarization.
Not necessarily the hyperpolarization, but for example, I guess you could call it that, not at this point, like right after active potential wouldn't contribute to it, but say this one, is positive, this one's negative, this one's gonna let in sodium, this will let in chlorine. They both can kind of almost battle at each other. This one will go, and then this one will go, and it'll kind of keep the potential going like this. Because sometimes your body doesn't want this to become excited.
Yeah.
Does that make sense? So it's a way of regulating what's gonna go on in the cell, the charge of the cell. Does that help?
Yeah.
Okay, good. Any other questions about it?